Hello! 1, 2, 3, testing, testing. Hello, everybody out there in television land. We are nearly to the end of the week. Huzzah! It is Thursday. Happy Thursday, everybody. Unless, of course, Your temporal displacement at this point in time, relative to this particular time zone, is sufficiently far that today is still yesterday, or might even be tomorrow, relative to my position, in which case, good tomorrow or good yesterday. So, for those of you who are watching this at 3 a.m. local time, thank you so much for tuning in. It really does. It does mean a lot to me. However, just keep in mind that sleep is also important. So, anyway. Hello, everybody. No outstanding announcements that I can think of, so we might as well get right into the lecture material for today. So, yes. Here we go. Last time we were talking about functions. The concept of a return statement seems to be somewhat arcane for a number of you guys out there in TV land, and I should probably go over it a little bit because just once more, just to hammer it home, because it's you know, if you're not used to thinking about things like a computer thinks about things, then the idea of a return statement is perhaps a little bit arcane, and perhaps I can spice this description up with some other arcane secrets that happen deep within your computer system. So, so when we define a function, the whole concept revolves around the idea of input and output, right? We've mentioned input and output several times. It really is like the keep your feet on the ground sort of relative to, if computing were kung fu, then input and output would be a basic rule, like don't show your back to your opponent. So, with input, the inputs are fairly obviously specified, right? List of inputs. Going back to our previous example of the median function. Documents. Someday I'll have this brought up before the lecture starts. But sadly, today is not that day. So, going back to our median function here, it's fairly obvious what the inputs are, and it should be fairly obvious the manner in which those inputs are used. You have these three parameters which are specified. They function as variables, and if you provide them with concrete values, either in the form of, literal values or other concrete or other variables, the concrete values of those variables are passed into the function as inputs. These are the inputs. So when you specify a return statement, this is how you say this is what the function outputs. So when we have a return statement at the bottom of a function returning some variable, and that variable has been used at some point inside of the function, what we are saying is, okay, this is the output. We want this to be the return value. We want this to be the value that is calculated by the function. It operates in a fairly similar way to, if just to draw an analogy, if you have y equals mx plus b, right? Your traditional standard linear formula. In this case, y, the value that is calculated and given to y for any particular value of x, that is the output, right? So, if we were to write a linear function like that, our inputs would be x, m, and b, just assuming that they're variable, and then we would return m times x plus b. That would be the linear function. So the explicit designation to y is implicit in the actual definition of the function. However, it becomes explicit when you actually invoke the function in order to obtain a value. So if you say y is equal to linear and then 1, 2, and 3, some inputs, then you can execute, you can execute the thing, and y actually gets assigned the value of whatever the return result of the function is. So with this, what happens? So let me explain a little bit about how computers work. Well, I don't know if getting into the stack frames is going to be useful at this point. Ask me later about stack frames once you guys are all, once you guys have had some practice with these concepts. Anybody who's interested in stack frames, I'd be happy to explain it during office hours. But essentially, the mechanism by which your computer keeps track of functions is it has what's called a stack, and it sort of keeps stacking functions like plates. And because functions can call functions, right? So whichever the top plate is, that's the function that's currently being executed. It is invoked by the plate, the function underneath it, and the inputs are given to it. And then once it produces its output, it takes that output and it gives it to the plate that it's sitting on top of, and then it's removed from the stack. That's kind of the very quick way of describing what the function stack is. So yeah, the return value specifies the output of a function. If your function does not specify a return value, then it returns nothing. And given that all of the functions that you'll be required to write for the purposes of your assignments, etc., all of these functions require you to specify an output. So if you don't know how a return function works, or a return statement works just yet, try it out a few times, and you'll see the difference. Cool. And remember, a function has to actually be invoked to be executed, not just defined. Let's see if we have any questions. Don't forget to like, comment, and subscribe. Hit that little bell icon so that you get notifications whenever a new video is currently streaming. Unless it's an unlisted video, which is all of the videos, so there's actually no functional purpose to hitting the bell icon other than to hear the little ringing sound. I don't think the bell icon actually makes... You know, I've never actually hit the bell icon, so I don't know if it goes like, ding! It should. Anyway, why do some function statements not have any variables, just empty brackets? Oh, that's a good idea. That means that they take no inputs. That's a good question. So sometimes you want to write a function that's just like define, do something, and then it just has no inputs, and then it like, return 5 plus 6 plus 7. This is just a function that takes nothing and gives you something. You get it for free, so to speak. Perfectly valid syntax. It just means it doesn't specify any input variables. There are some functions like that. Sometimes they sort of operate implicitly on values that have been stored in global memory, where the use of global memory is, generally speaking, strongly discouraged. So, but we'll get into how to use it, because in this class we don't shy away from discussing the dark arts. So, yep. Cool. All right. So, for example, Pythagorean theorem. If we have the, so if we want to define Pythagorean theorem, all we need to do is def Pythagoras. Not sure I'm spelling that correctly, but okay. It takes an x and it takes a y, or it maybe takes an a and a b, since we're calculating c squared. And then c is equal to a squared plus b squared. And then we return the square root of c. Incidentally, in Python, raising something to the power of 0.5 is shorthand for performing a square root operation. The alternative to that is you have to import math, and then you have to use math.squirt. Again, I don't no idea why they call it that, but they all do. Every programming language calls it that, pretty much. So there you go. So then, if we wish to invoke the Pythagorean thing and actually print something, we can print Pythagoras 3, 4, providing inputs 3 and 4, Python 3, topic 1. I suppose I should be doing this in topic 2. Oh well. There you go. So, ignoring the output that we had for previous sections of this class, you can see that the return result is 10. Or 5. Sorry, 5.0. Because, of course, taking a square root results in a floating point result. So that's what the 0.0 means. Even if it's a whole number result, it'll still be floating point. Cool. What happens when we type the following code? A is equal to 4, B is equal to 5, 3a plus b. I already did this, but if you want to do it again, Python 3, open up the interpreter. 3a, let's say, let's do it with just literals. 5 plus 8. Of course, this is an error. The int object is not callable. This is the syntax for calling a function, which means that this is not implicitly multiplication, which is the case in algebra. This is another one of those differences between programming and algebra. If you want to multiply, you must actually use the multiplication operator. There you go. So, things are about to get a little bit more complicated. Let's just take a moment. Let's breathe. Because we're about to talk, things are about to get more complicated. I'm gonna, does anybody have any questions about what we've done so far before we get into the next major subtopic within this topic? Why will it be floating point even if the square root is a whole number? Very good question. So that's because, it comes back to that idea of output. So the square root function that's defined inside of the math library, it has a fixed type that it outputs, right? So if we import math, right? If we do math dot square root, there we go. What? No, stop. There we go. If we want the square root of 8, we get a floating point number, right? If we want the square root of 9, we still get a floating point number. It doesn't matter what thing you put into there, the function is always going to give you back a floating point number. And part of the reason for this is because the actual calculation that's going on underneath the hood requires floating point numbers. It translates, if you give it integers, it translates them into floats first, performs the calculations it needs to perform to find the square root, and then it doesn't bother converting it back to an integer if it's a whole number, because it's actually non-trivial for a computer to decide when it's appropriate to convert something to an integer or when it isn't. You can imagine that, like, if you had something like 0.9, 9.0000001, took the square root of that, you know, this might be, you know, if you had rigged up the computer to automatically round something, you know, if it's within a certain, you know, distance from the whole number, this might actually be an important result that you would lose if it rounded. So the computer just doesn't. It says, if you want it rounded, you round it. You know? The computer is not going to decide for you whether or not that number should be rounded. You have to decide that. And, you know, that's... that sort of gets into this interesting thing with programming, which is like, what does the computer decide to do, and what do you have to tell it to do? In Python, generally speaking, in comparison to most languages, Python will take a lot of responsibility on itself for doing a lot of these sort of micromanagey type things. A programming language like C will do nothing. Absolutely and precisely none of this work for you. But there are some things it'll do and some things it won't. How would you make the square root of the number to be an integer instead of a floating point? Do you write int in front? No, that's the C method. The C method would be to cast it. So you would do something like this. Maybe that works. Nope, it doesn't. No, in Python, you would do one of two things. You would either call it like this, right? So any type name is also the conversion function, and we're going to see how this works a little bit later on. So any type name is a conversion function. The other way of doing it is doing math.round. You can also use ceiling and floor if you want to round up or down. But, oh, maybe you don't have to import round. Maybe it's just there. It's just there. Yeah, the other way is to use the round operator. And the advantage of the round operator is that you can actually specify the number of digits you want to round it to. But that's, you know, neither here nor there. Doesn't exactly pertain to this particular example, but it's useful to know. The solution to having the computer make life decisions for you. Maybe make a magic 8-ball program. Oh, man. Oh! Ooh! Ooh, that would make a good test question. Ha! Ha! That would make a good test question. Okay. Pardon me for just a moment. Magic 8-ball test question. Boop. Well, you know, the test questions are gonna be something, right? So it's not like if I don't hear any suggestions from the class that, you know, I'll probably just come up with something harder than that, you know? But anyway. No, that's actually a pretty good idea. Although, now that I think about it, the essential element of a Magic 8-ball program is random number generation. So you'll notice that during all of these things, it's like we're never going to... Well, we will rarely use random number generation in anything that's testable, because the test cases need to be repeatable, and random number generation is not repeatable. So that being said, you could always have like the randomly generated number as an input to the function, and just have it return, you know, a number of different strings based on what the random number based on what the input is. So you just abstract the random number generation out of the question, and yeah, it could work. No, that is an easy question. All that needs is if statements. Perilous error. Yeah, I know. Don't worry, guys. Test 1 won't be too bad. It'll be test 3 where I get you. And I'm only half joking. Where were we? So, tuples. Okay. So, This bit is probably going to let's say this particular topic is gonna be some chunky marinara for your head spaghetti. So let's take this at a leisurely pace. So we're going to talk about collections of data. The first one that we are going to talk about is the tuple. So if you have done programming before in other languages, what we are currently talking about is lists or arrays. These types of linear data collections. In Python, you have a bunch of these different types of things. So learning the names is important. We have lists as well as tuples. So just, don't worry. We've got summary slides and everything that shows out the difference. For those of you who have never heard of a list, a tuple, or an array before, I'm going to draw once again on our knowledge of mathematics. Basically, we're talking about vectors, right? So vectors in the sort of more abstract sense, in that they can have as many, technically speaking, a vector can have as many things in it as you like, right? A vector doesn't have to be like with 3 elements like you're doing it in 3-dimensional space. Vectors can be extended to n-dimensional space. So that's roughly the analogy that we're working with here. Most broadly, a tuple is a collection of objects. So, and the advantage of putting things into tuples is that you may refer to them by index rather than having a separate name for each one. Technically speaking, there's nothing that you can do with a tuple that you can't do with individual variables. It's just organizing things into a tuple makes it much easier to work with larger sets of data. So, for example, let's say we had a tuple and it contains the numbers 1, 2, 3, 4, 5, 6, 7, 8, and 9. Right? If we ask to see it, it is what it says it is, right? It's printed out in the manner in which we've defined it. So, if we wish to access the second, well, yeah, starting to get into it already. So, with these types of data structures, and this is more or less universal across programming languages except for MATLAB. MATLAB uses a different way of doing it. The first element of a data structure is element 0. This is called zero indexing. So, if you want the first element, you use t at 0. I'm going to pronounce this at. T at 0. If you want the second, t at 1. If you want the third, t at 2. Etc., etc., etc. This is... So, we're going to get into how this works, but essentially, it's possible to write a loop so that it iterates through all of the elements inside of a collection of data. This is so common in programming that Python actually provides a specialized kind of loop, that does all of this bookkeeping for you, but we're going to learn how to do it ourselves as well, because it's always important to know how things are going, how things are happening under the hood. And, writing a regular loop that iterates through things using an index is something that you're going to have to do if you decide to program in any language other than Python, and it can be useful in Python sometimes too, despite the fact that Python has this advanced construct for it. Let me see if I've completely lost everybody. So, with respect to the types of the things inside of them. So if we have L, whatever, no, L is for lists, T2, the tuple can contain integers, it can contain strings, like potato. We have not talked about strings just yet, but we're getting there very shortly. You can have floating point numbers, and you can have Boolean values, all contained within a single data structure. This is not normal with respect to programming languages. This is a thing that Python does that very few other programming languages do. Normally, when you define one of these things, you would have to declare what the type is up front for all of the elements inside of the data collection, which, you know, that's because other programming languages work with a tighter memory map, so you actually have to know how much space in memory to allocate the thing that you're declaring. They also have to be declared with a fixed size, whereas in Python, both the management of the memory of the things inside of the tuple and the size of the tuple itself is carried out. All that is done in the back end, and you don't have to worry about it. So, cool. So you can put any number of things that you want inside of a tuple. You're basically only constrained by the memory constraints of the Python process itself. That is to say, you can't run your computer out of memory, but you can do pretty much anything up to that point. Although realistically, well, in some languages you're constrained by the size of an integer to the number of indexable items in it, but, you know, this is Python we're talking about. There are no hypothetical limits. There are only practical ones. So, yes, one of the very important aspects of a tuple is once you've put things into a tuple, the things stay where you put them. So the ordering is stable inside of a tuple. That's not universally true. So don't worry about it. For now, everything is stable and rigid. And you can also assign a tuple to a variable, as I demonstrated, and you know, access the various elements in it and perform other operations on it. You don't. That's the whole point. The whole point is that you can name it something and then deal with it by its name rather than individually all of the elements. Again, this is a mechanism of abstraction. This is an abstraction method for data. So, yeah, you'll see in programming generally there are two large classes of abstractions. You have abstractions for instructions. That is that's the function, right? You also have abstractions for data. That is data collections. And toward the end of the course, we're going to have a marriage of convenience between those two types of abstractions when we talk about classes. But you know, up to that point, you don't have to worry about it. So here are some basic operations on tuples. We've already talked about how to access the ith element. Keep in mind, everything is zero indexed, right? The first element is element 0. It's just like in Mass Effect, element 0. Wow, that is going to be an obscure reference and only available to anybody who read the codex data in the first couple of Mass Effect games. There's some interesting stuff in there. Anyway, so another one is concatenation. Concatenation might be a term that you've never heard before, but it basically means smushing together. So if I have T3 is equal to T plus T2, plus is concatenation. So T3 is the first one concatenated with the second one. The first one and the second one are smooshed together and merged into a list in the order in which they were concatenated. So there you go. And that is bound to the plus operator. So you can also, this is actually going to be a very useful and familiar one to you by the end of the course. You can use len to take the length of the tuple. It's super useful to be able to tell how big a tuple is inside of your code. So this function will be of use to you. In Python, in comparison to a number of other languages, Python has a searching operator that's built right into, like, it's not a function, it's a search. All right, it's technically a function, but what it's doing, like, it's not using function syntax, is I guess what I'm supposed to, what I'm trying to say. So if we want to say for in t, true. 10 in t, false. So all it's doing is it's taking a look at every single element in t and performing an equality operation on each of those elements between the element in t and the element that you're searching for. When it finds an element that matches inside of the data structure, it says, okay, I can stop, I found it. And then it returns true. If it reaches the end of the data structure without having found the thing you're looking for, it's like, well, I guess it's not in there. I'm returning false. If you wish to take the negation of this, then you just put a not in there, and 10 not in t is true, but 4 not in t is false. So there you go. Are there any questions? My microphone looks like a top hat. Yes. Ooh. Am I cutting in and out? Cool. So, in the list, there is the Boolean value. Yes. Are you able to call the element in that list and use it as a true false function? Yeah. Well, I think what you're intending to ask me is, can you use it in an if statement? And the answer is, you absolutely can use it in an if statement. So, geez. There we go. So that is t2 and element 0, 1, 2, 3. So element, there we go. If that's true, print it's true. Else, print it's a lie. It's a lie. So yes, you can use, and you can do this with variables as well, not just tuples. If you can store a Boolean value inside of a variable and then refer to that variable later in the code for the purposes of an if statement or a loop or some other conditional. Generally speaking, we have a specific term for this within computing. We call this setting a flag. A flag is a Boolean variable that you set at some point in your code, normally to be able to tell whether a specific branch of your code executed or not, so that you can refer to it later to see, if something happened in the code through that execution. But, we'll get into that sort of thing. For the in function, can you perform it to search for strings? Let's see. Potato in T3. True. Yes, you can use it for strings. Can you do something like 2 times t and double the values in the tuple? No, that has a different function. We haven't quite gotten it to it yet, but 2 times t actually means writing t out twice and concatenating them. So that's fun, because you can easily do stuff like 9,001 t's. It's over 9,000. So yeah, you can just, if you ever want to generate spam, then you use that multiplication operator. Good. Are programming languages different in different languages? Like, The built-in operators would be different in German, French, Spanish, etc. I don't think so, actually. Possibly. Let me put it to you this way. Probably there are languages that have language packs that would change the keywords. That I could easily see happening. But if you want to download, like if you get the default installation of any of these languages, you're going to be programming in English, my friend. And that is, that's, I think, a result of all of the code base for these languages being originally written primarily by people from the British Isles and America. So there you go. So while I'm sure that language packs exist, which will translate the keywords, the sort of base instances normally in English. What's the difference between lists and tuples? Lists are mutable. Tuples are immutable. We'll get into the difference in a little bit. Yes, the power level was too great. Cool. So that's some basic tuple operations. Here we go. Tuples are immutable. We can't change one entry of a tuple. So one thing that's normal, I'm just going to define a list for you just to be able to see the difference. The difference between tuples and lists, generally speaking, is lists are mutable, tuples are immutable. Don't worry, we'll get into what the difference between those are, but I'm just going to define a list and show you what the difference is. So if we've got T, that's that. List is that. Tuples have round braces. Lists have square braces. If we want to, say, change the value of the third element of the list L to 9001, then it just changes it. If we want to perform the same operation on a tuple, we are barred from doing so. A tuple may not be modified once created except by specific methods. Like when you concatenate two tuples together, you're not actually modifying the underlying data. All you're doing is you're creating a new instance, a new segment of memory that contains both of the old ones, and the old ones aren't modified. This is what it means to be immutable, with some caveats, but that's generally speaking what it means to be immutable. So, it's important that tuples are zero indexed. We start counting at T0. I have already illustrated that point. So yes, you can't perform assignments. You can, however, that's a good point, you can assign a variable from a tuple. So you can extract the values out of a tuple, but you can't modify a tuple once created. Anytime you think that you're modifying a tuple after you've created it, you're actually not. You're just destroying the old instance and creating a new one. Like, for example, if I say T is equal to T plus 1, 2, 3, concatenate 1, 2, 3, there it goes. But this is a new tuple in new memory that has been assigned to the variable. There's an important distinction between the data as stored in memory and the variable name. We're going to get into it, though. That's like next slide set. We're going to get into it pretty heavily, so I won't belabor the point at this point in time. So, strings. Strings. So, when we say strings, you'll probably have heard me use the term string. A string is a string of characters. So when we operate with a computer, everything that we're looking at here, these are all characters. If you wish to operate on characters directly, you must enclose it in quotes. So, hello, world. World. Are you guys surprised it took me this long to get to hello, world? So, when you enclose a set of characters inside of quotes, what you are doing is you are saying this is not code. These are character values that are operated on in the same way as you might operate on integers or floats or other data types, right? This makes it data rather than instruction material. Yes. So if you take the type of this, you will notice that it is an str or a string. There you go. So, in Python, you can use either double quotes or single quotes to represent strings. They are interchangeable, and there is no difference. There is literally no difference. You may notice that in in this particular statement, I gave it double quotes, and it spit back single quotes at me. For whatever reason, the default is for when you print stuff for Python to throw single quotes up rather than double quotes. Notice, however, that when I print it, there are no quotes, right? That means that this is just being shown. It's not like, well, the difference is kind of technical. But anyway, so for all my programming bros out there, this is a big, this is a big, hairy, nasty distinction between Python and pretty much every other programming language you'll have ever used. Python does not recognize characters as a data type. A character in Python is a singleton list, or a singleton string. So characters are dealt with as strings containing one element. Don't ask me why. I have no idea why. I think it's dumb. But this is the way that Python has chosen to do it. So, strings are not character arrays. Characters are singleton strings. That's what you have to wrap your head around in Python. So, you know, it's not too bad once you get used to it, but, you know, so to the rest of you, the reason I'm explaining this to the people who know programming is typically, in a programming language, single quotes denote characters, individual characters. So if I were to write, you know, just the exclamation mark, if I enclose it with single quotes, that makes it a character, and if I enclose it with double quotes, that makes it a string, and there's a big difference between the way that you use those. In Python, you just have strings, so there's no difference. Everything is a string. So yeah. Questions? Ooh. Why would you ever use a tuple as opposed to a list? They're more efficient memory-wise, and they're a little bit faster too. So to make, also when you don't want people to modify the data, so when you make an add to a tuple is, yeah, so it's a little bit, so for tuples, and this actually goes for everything. When you use the square braces like that, that's indexing. That is the indexing operation. That is, if you use round braces, that's a function, right? That's a different thing. That's a function. However, if you use square braces, that is an index operation. They're two very different operations. And yes, when you define a tuple up front, you define that it's a tuple by using round braces. Round braces are for tuples. Square braces are for lists. Curly braces are for sets and dictionaries that we haven't talked about yet. Those are the exotic ones that I mentioned. Can you subtract stuff out of a tuple? Yes, but not by that mechanism. You can't just use the subtraction operator. You would use what are called list slices. So we're going to have lots of slides on slices, but yes, you can subdivide lists to access sublists. You can subdivide tuples to access subtuples. But yes. Java has a difference between single and double quotes. Does Python have a difference? No. Yes. Can you use both? No. So that's one rule. If you use a combination of the two, it won't work. A string has to be closed by the same thing it opened with. One thing that's useful with this double thing is my programming bros know that normally in order to get a quote character into a string, you have to use what's called an escape character. We'll be using escape characters a little bit later on, but this is roughly the syntax for how you would define. This is how you would define quotes within a string in any other programming language. In Python, you don't have to do that if you use the other type of quote. So that's one, like, you can use single quotes if you need double quotes in your string. That will work. And it works the other way around, too. But that's kind of arcane nonsense that doesn't necessarily need to exist right now. Can you index characters in a string? Very good question. The answer is yes. You absolutely can index the characters inside of a string. There's a reason that we're doing both tuples and strings at the same time, right? Fundamentally speaking, they're actually the same thing, like, under the hood, right? Pretty much all of the operations that work on a tuple will also work on a string. So, for example, if I want to do hello plus world, it concatenates the strings. If I want to take the length of that, you can take the length of that. All of these operations that are valid for tuples are also valid for strings. And the other thing that's interesting about strings is that they're also immutable, just like a tuple is. So really, from a semantic standpoint, strings are just tuples that only contain characters. Although, because this is Python, characters don't exist for some reason. Yes. So, your Python has, yes. So, you have an infinite loop. You have to stop it or kill your kernel. For the star in Jupyter. When you modify the tuple, is that the new tuple, or is there a way to recall the original list? Or the original tuple? Yeah, so if you assign something like that, T4 is the new one, and you still have access to the old one. Yeah. So, why is hello1 output H? Capital H. Well, because it is a capital H in the original string. So, yeah. It looks like space counts towards length. Very astute observation. Yes. Thank you for noticing that. So, in regular writing, like writing stuff out, we don't typically consider space to be a character. But in programming, like, it's interesting. The space character is like an actual number that's held somewhere in the deep bowels of your computer system. So yeah, space characters are characters, and if you they don't count as non-space, right? They exist. Spaces exist. Spaces exist. The same thing is true for tab characters. The way that you do a tab is like that. Cool. And if you want to do a new line character, that's /n. So you can add new lines to your strings as well. Yeah, cool. So there we go. There we go. Wonderful, wonderful, wonderful. This is good. Das ist gut, ja. So, I think that's about the duration of class for today. I'll stick around for a few minutes longer, but if you have any real, if you have any really beefy questions, then by all means swing by my office hours, which are occurring from 10:30 to 11:30 today, and we'll get those questions answered. Dankeschön. So, how much does a tab character count to a length? Well, it's one character, so it contributes 1. Even if it's printed out as multiple characters in the terminal, in here, the /t, that counts as 1 character. So the length of 1, 2, 3, 4, 5, 6, 7. 7. There you go. Can I play Hexy-Hashy? I'd have to log into my Windows side. So, nah, it's okay. One shouldn't mix too much the work and the pleasure. And besides, there's like an hour or two of me playing Hexy-Hashy up on the channel already, you know? What should a perfect assignment question answer contain? It's a weird question. The assignment questions are all of the questions are being evaluated strictly on the basis of for these inputs, do you produce the correct output? There's no technical requirement to provide anything other than that. And there's no requirement for you to be producing the answer in any particular manner either. You guys are learning code for the first time. Sometimes programming is taught like, if you have this problem, this is how you approach it. If you have that problem, that's how you approach it. And you're being marked for using the approach that the prof has specified, as well as getting the correct answer. In this particular instance, I think, well, like, we don't do that. I think it's a bad way of teaching people programming. In order to understand programs as a tool for manipulating data, you have to think of them as a tool for manipulating data. It's like, I start here, I want to end there, these are the tools I have available to me, right? You're going to make, like, mistakes, and you're going to come up with highly inefficient solutions. That's natural. It's because you're learning, right? So we're going to try not to penalize people for learning during a course, essentially. So, yeah. You're welcome to approach the problem from any methodology that you wish. You're welcome to try the problem in any, you're welcome to take any approach to the problem that results in a correct solution, where correctness is defined as, if I provide your function these inputs, I should get that output. Hopefully that answers your question. Often I feel the methodology is sort of implicitly suggested inside of the question itself. But that's because, if I don't write the question directly, I certainly review the question before it's sent out. Sometimes one of the TAs writes questions. The TAs are pretty good. Goku or Vegeta? Oh man, getting into the hard-hitting questions today. I never actually watched the show or read the manga or anything, so I'm just gonna have to say Vegeta because he's the underdog, and you gotta love the underdog, right? I mean, Goku is basically Superman, right? And thus, maybe I don't know. Maybe they managed to avoid that thing with where Superman is like the most boring character because he doesn't actually have any conflict to overcome. That's why they had to invent kryptonite, so that there would be some thing that would like cause any amount of drama or interest in the plot whatsoever, you know? So a character that's not like God is always more interesting in my view. But anyway, I have a question regarding how to submit the assignments. Should I ask here or in office hours? In office hours, we can do the screen share thing, so I can actually, you know, show you what button to press. So, yeah. Okay. Well, I guess I'll cut it off here. Thank you very much, everybody, for sticking around, listening to your poor old professor waffle on about stuff for an hour. I'll be starting up the office hours right quick, so don't touch that dial. Well, actually, you'll have to touch that dial because it's on a different channel. But anyway, so touch that dial. Take her easy, folks. Talk to you again soon. See you next week. Have a good weekend.